Okay, so right here, down here, we have space fabric right here in this equation. I think it is. I'm not sure how to make omega, but the rest of this didn't have anything to do with anything, so I erased it. I put it up here in the magnetic paradox, and it was wrong right there because mass and mass don't go together like that. So right here in the magnetic paradox, instead of doing what I did, I put mass times velocity congruent to k in parentheses times space fabric plus momentum times variant congruent to I, and then plus t minus force plus motion times acceleration to the congruency of xy to phi. And what I came out with was this. Not this part that I'm covering, but the rest was all the same truth. And I figured it out that I already tangented it out, but I didn't figure it out yet until I just did it now today. And the other part about what I was talking about was time to the third, and that's right. That's right here. And I guess that's what I started out with and how I got to the end of it. Except for this should be maybe h bar squared somewhere, or no, there's no h bar squared. It's just the wavelength, I think. This is h bar squared right here, and not h bar squared right there. But I don't really know. I'm not used to it yet, and it's the dimension of time, so I'd have to come up with a superplex of it or a complex of it. And yeah, that's what I think is the easiest way to go about doing this, is with this one right here. Makes this, which is like, so there's kinetics and there's an absence of light because of the kinetics moving so fast on the mass or energy. You can call it energy or mass, but this is the conservation of motion, and this is the, or this is the relinquishment of motion, and conservation motion happens right in this area right here. It's continuous for a while. And in thermodynamics, you would call this a variant for force and heat. I think that's how it works out, but